Hello, this movie is in Unit 8, Learning Target 1, the Pythagorean Theorem and its converse. So, if you know the lengths of any two sides of a right triangle has a right angle, then you can find the length of the third side using the Pythagorean Theorem. So if we have A, B, and C, we know A squared plus B squared equals C squared. So given any two sides, we can find the length of the third. Now keep in mind, it's the leg squared plus the leg squared is equal to the hypotenuse, and the hypotenuse is always the side opposite the 90-degree angle. So you got to make sure C is always the hypotenuse. We learned about Pythagorean triples, and this is a set of non-zero whole numbers A, B, and C that satisfy this equation, and they give us whole numbers. So we have a 3, 4, 5. 3, 4, 5. 3 squared plus 4 squared equals 5 squared. 25 equals 25. We get a true statement. Now, any variations of these, such as we take this and multiply by 4, we would get 12, 16, 20. That's a 3, 4, 5 dilated by a scale factor of 4. So this is considered also Pythagorean triple, but the triple that we use is a 3, 4, 5. Other such popular triples include 5, 12, 13. 5 squared plus 12 squared equals 13 squared. 8, 15, 17. 8 squared plus 15 squared equals 17 squared. And 7, 24, 25. 7 squared plus 24 squared equals 25 squared. And if you can memorize these Pythagorean triples, these 4 specifically, then your ACT will be that much easier. It's one of those ideas that is very helpful on the ACT. So let's use our Pythagorean theorem in practice here. Notice our longest side, the hypotenuse, is 20. So we have leg squared plus leg squared equals hypotenuse squared. Please note, 20 is not a leg. X is not always the right or the side opposite the 90-degree angle. So we get x squared plus 64 equals 400. X squared is 336. Now for time purposes, we're going to leave it as square root of 336, which is our exact answer. It does say simplest radical form. For right now, we're going to leave it as square root of 336. The converse says, if a squared plus b squared equals c squared, then we have a right triangle. So if we have 3 values that represent 3 lengths of the side of a triangle, and we plug it into a squared plus b squared equals c squared, if we get a true statement, then we have a right triangle. Right here, a triangle, let's look at A. A triangle has side lengths 16, 48, and 50. How do I know which one's the hypotenuse? It's got to be the longest side. So 16, 48, and 50. Is the triangle a right triangle? Well, let's see. 16 squared plus 48 squared. Does that equal 50 squared? And so you get no, because 16 squared plus 48 squared is not 50 squared. So this is not a right triangle. B says, once you know which lengths represent the hypotenuse, does it matter which lengths you substitute for A and which one for B? No, it doesn't, because A squared plus B squared is the same as B squared plus A squared. So it does not matter. Now, before we go to the next slide, I want to research something here real quick. We are convinced when we have a right triangle And if you're able to draw this in your notes, that would be great. Let's say we've got a right triangle here. We've got A, B, and C. When we have a right triangle, we know that C squared is equal to A squared plus B squared. But what I want to investigate now is what if C squared is less than A squared plus B squared, meaning it's not as long as this C. So what if I took A, carried it in a bit, but kept the length of A? So A is now here, and C is shorter. What does that mean? What kind of triangle is that? Well, it's not a right triangle, which this one is a right triangle. This triangle is what we call an acute triangle. So where all three of our angles, oh, that was bad writing, are less than 90 degrees. Now the question is, what if C squared is greater than A squared plus B squared? Let's see what happens here. So that means we're taking A and we're going to extend it out, but keep the length of A. So there's A. And C is now longer. It's been elongated. And when C squared is greater than A squared plus B squared, we get this triangle, the orange one, which is an obtuse triangle. Now, hopefully you can see that here in this diagram. When C squared is equal to A squared plus B squared, we get a right triangle. If C squared is less than, we get an acute triangle. And if C squared is greater than, we get obtuse. So notice we are always evaluating with C squared on the left. When C squared is greater, we have an obtuse. When C squared is less than, we have an acute. So that's what we're going to analyze here. A triangle has a side length 6, 11, and 14. Is it acute, obtuse, or right? Well, if this were a right triangle, 14 would be the hypotenuse. So I'm going to analyze with 14 first. 14 squared and say, how does that relate to 6 squared plus 11 squared? If it's equal, I've got a right triangle. If 14 squared is greater than, then I've got an obtuse, and if 14 squared is less than, I've got an acute. Always put C squared on the left. That's a little trick to the trade. What we get here is 196, and then on the other side we get 157. So C squared is greater than, we've got an obtuse triangle. Pause the movie, try number 5, and then press play when you are finished. On 7, 8, and 9, 9 would be the hypotenuse. So I'm going to analyze 9 squared. And how does that relate to 7 squared plus 8 squared? Well, 9 squared is 81. 7 squared plus 8 squared is 113. So 81 is less than, giving us an acute triangle because C squared is less than A squared plus B squared. All right, pause the movie, try both 1 and 2, and press play when you are finished. In number 1, 12 is the longest length. So I'm analyzing 12 squared. How does that relate to 8 squared plus 9 squared? So we're looking at 144 and 145, and that is less than. Hence, we have an acute triangle. All three angles are less than 90. In a 5, 8, 6, we know 8 would be the hypotenuse. So we're analyzing 8 squared. How does that relate to 5 squared plus 6 squared? Well, this is 64, and this is 61, and that's greater than, so we have an obtuse triangle. And that's the end for our movie on Pythagorean theorem.